I'm Paine and I'm a Professor of Infrastructure Materials in the BRE Centre for Innovative Construction Materials here at the University of Bath. By background I'm a concrete technologist, which means principally I'm looking into ways in which to make concrete more sustainable.
My name is Susanne Gebhard. I'm a senior lecturer in our Department of Biology and Biochemistry, and my day job is as a microbiologist, so I work with bacteria. And broadly what my lab is interested in is how bacteria cope with stress and stressful environments. But these are prefab slabs?
No, this is in situ. This would have been cast in place.
What we want to work in the concrete is bacteria that are happy with the limestone environment, with the pH and the calcium.
About 50% of the UK's construction budget is spent repairing materials that already exist, and most of that is going to be concrete, because concrete is by far and away the most widely used construction materials. The great advantage of self-healing concrete is that the concrete is repairing itself in situ. The way the technology works is we make the concrete as normal, but we've added inside the concrete some capsules containing bacteria. Once the concrete cracks, the bacteria is released into an environment where hopefully the bacteria are to some extent happy.
When we grow the bacteria in the lab, we typically grow them on things like this, which is a petri dish with some agar in there and has some nutrients for the bacteria. And if you do this under the right conditions, and if we give the bacteria some calcium, for example, then the right bacteria can form crystals out of the calcium. We have a crack in the concrete, the bacteria can grow in that crack, and then because they make that mineral, that will eventually seal that crack up with this lovely mineral crystal layer on the surface of the crack and make it watertight, which is what we want.
We've got a piece of self-healing concrete here. It was made probably, 4 or 5 years ago. It was cracked and it was allowed to heal, and all that's left is a very tiny scar.
When we first had that very first meeting about doing this project, and you guys wanted the bacteria to do something, and you went like, oh, I don't know if this is possible. And for me it was like, oh no, this is really easy, bacteria are really good at this.
Yeah, I think the funniest thing is that when I first started, biologists call bacteria bugs, and so I copied them. I said, oh, we're putting the bugs into the concrete, and they're like, no, you can't call them bugs, they're bacteria. And it was only after about 3-4 years of doing this, Susanne said to me, Kevin, you're now allowed to call them bugs. I think we could have even more fun by actually using the technology that we've developed that goes inside the crack, actually to maybe even grow buildings, or grow elements for buildings themselves, and do other things with the technology.
And other materials that maybe would work better if we put the bacteria in, because I mean, we're talking about limestone. Basically, there's lots of use for that other than concrete. I think this is the most fun I've had with research in a long time, and it's that, like for me, because my background is so molecular and all these little details of what things inside bacterial cells do, and now we can have like little bits of concrete that we can take places and show to people, and everybody understands that there is a crack in the concrete and the structure breaks, and then we can show them that it really works. So I find that's been really fun, to have something really visual and to talk to your friends and family about what you do.